All right. So there is a relationship between the exponential function and the logarithmic function. And we've kind of seen that because we know we can interchange the two. We can go from one to the other using our definition. And we want to investigate that a little bit more today. So what we're going to do is graph each of them. When I had you graph exponentials, what did I always tell you had to do? How many points? 3. What values did we plug in for our x? -1, 0, and 1. So if I wanted to graph y equals 2 to the x, and we always did essentially a t-chart, whether or not you wrote it out, we put a -1, 0, and 1 for the x values. So 2 to the -1 power is 1/2. 2 to the 0 power, and 2 to the first is 2. So my points. We have -1, 1/2, 0, 1, and 1, 2. And we know when we graph this exponential, it had a horizontal asymptote at 0 because 2 to a power would never equal 0. So it looked like this. What is the domain of that function? Every exponential had a domain of everything. What was the range? Now, let's look at a log. So if I asked you to graph this, we need a t-chart. And you can get it from here, but it's sometimes a little bit harder for people to think about. If you don't like it written in logarithmic form, what could we do? So it would be 2 to the y power equals x. So my exponent is now y. So if we plug in our -1, 0, and 1, we always put those in for the exponent in an exponential, which is the y. What is 2 to the -1? What is 2 to the 0? And 2 to the first is 2. So my points are 1/2, -1, 1, 0, and 2, 1. Okay, will we ever get 0 out? No, we've already talked about with the log, the argument has to be a positive number greater than 0. So what kind of asymptote does this have? A vertical asymptote at 0. The domain, we've talked about it already for these logs, but we can see it from the graph. It's just everything bigger than 0. What is my range? So what is the relationship between the log and the exponential? They're inverses. Look at these ordered pairs. -1, 1/2 became 1/2 -1. 0, 1 became 1, 0. 1, 2 became 2, 1. If you graph the line y equals x, it goes right through the middle. They are reflections across that line. Y equals x. My horizontal asymptote became the vertical. The domain of the original was the range of the inverse. Range of the original is the domain of the inverse. So the log and the exponential are inverses of one another, which means the x and y just flip roles. Okay, I want you guys to practice graphing a log. So just always change it to exponential form and graph it like we did the exponentials, plugging in your 3 points. So try to graph that one for me. 3 exact points. So the exponential form. F of x is the same as what variable? So it's like 1/3 to the y power equals x. So when you make your t-chart, since y is the exponent, you put in the -1, 0, and 1 for the y. 1/3 to the -1 is 1/3 to the 0, and 1/3 to the first. So our points. 3 -1. Oops, I did not graph that correctly. 3 -1, 1 0, and 1/3. If we look at this, we know it should have a vertical asymptote because an exponential had a horizontal. So it looks like that. Domain. Range. Okay. Let's do some transformations with these. So just like we did with exponentials, if I asked you to graph a transformation, I expect a parent function. Your parent function is your basic exponential, or basic log, I guess. It will change to an exponential in order to graph. So if I'm looking at this first one, f of x equals log base 3 of x plus 2. So what log would I use for my parent function? Log base 3. Okay. So if we think y equals log base 3 of x, that means 3 to the y equals x. So my y is -1, 0, and 1. 3 to the -1, 3 to the 0, and 3 to the first. So -1/3, -1, 1 0 3 1. This is my parent function, so we always do that dash. Then what's the transformation? If I move this left or right, what else moves? Right. We had a vertical asymptote at 0. So now that will get shifted to -2. So we move each of our points to the left too. What is the domain of that one? And the range? Everything. Alright. Let's look at the next one. F of x equals log base 4 of x plus 2. What will we use for the parent function? Log base 4. So as exponential, that would be 4 to the y equals x. So if we make our t-chart, y is the exponent, so that's my negative 1, 0, and 1. 4 to the negative 1, 4 to the 0, and 4 to the first. Negative 1, 1, 0, 4, 1. Parent function, so dash. What is our transformation this time? 2. Will my asymptote move? No. If you move left or right, it's going to move your asymptote. Up and down will not. So. So what is the domain of this? And the range? Is that okay? Let's try, why don't you guys see if you can sketch graphs for those two, and then we'll check.
I'm going this year. I'm not worried about next year. I'm on this really good time.
Alright, so here are your two parent functions. Did we get those correct? So the log base 1/3, log base 4, change them into exponential form. What's the transformation on the first one? And if you move left or right, that moves our vertical asymptote. So now we have a vertical asymptote at positive 2. We'll move each of our points over. Alright, what's the domain of that? And the range? Alright, this one. We start here. What's my transformation? Okay, so if I move each of my points down 4. Does my asymptote move?
No.
So it will look like this. Vertical asymptote stays the same. Domain?
0 to infinity.
Range? Are those okay? I want to do one last problem that involves some different transformations. So what is my parent function for both of these?
Something that you have to memorize, I mean. Something that keeps me up in my nightmares.
What's our parent function?
1.5.
So we'll plug in -1, 0, and 1 for the exponent. So 5 to the -1 is 1/5. 5 to the 0 is 1, and 5 to the first is 5. Alright, so then our points would be 1/5, -1, 1, 0, and 5. Okay, let's think about these transformations. Log base 5 of 2x. It's been a while since we've had one of these. If something is attached to the x, then it's a horizontal change, right? And it does the opposite of what we say. So multiplying by 2 means we would divide our x's by 2. Okay, so it's going to shrink it or compress it horizontally. So if we basically just think about this, we could take our x's, divide them by 2. So this is 1/5, so it's going to go to 1/10. This x is at 1, divided by 2 would be at 1/2. This x is at 5, divided by 2 would be 2.5. So extremely similar graph, but it shrunk in. What if we had log base 5 of negative x? It's taking all of your x's and making them negative, so it flips it over which axis? If you take your x and make it negative, it'll flip over the y. Okay, so I'm taking my original x's and reflecting it. All right. Any questions there? Amazing mathematician. Last example I want to do. We've been finding domains by looking at the graphs, which is fine, but it's helpful to be able to find the domain without graphing the log first. So let's say I give you this one. If I wanted to find the domain and I don't want to take the time to draw the graph, how can I get there? Okay, you could think about your transformations, knowing it would start at 0 and the -1 would move it right 1, so your domain would become 1 to infinity. The other way to think about it is we know the argument has to be positive. So x minus 1 has to be greater than 0, so x has to be greater than 1. Isn't that the same thing? So you can either work it out or just think about your graphs. But I do want intervals at the end. B, if I'm thinking about the graph, what would this one do? Down 1. Does that change your domain? No. If I'm thinking about it algebraically, my argument is just x, so x is greater than 0, so it's still just 0 to infinity. That one's tricky.
So the absolute value of x is greater than 0.
Mm-hmm.
So it would just be
Negative
infinity.
infinity to pi.
Almost.
It would have to be.
Oh, wait.
It's
Negative infinity to 0 is very positive.
Mhm.
Uh,
So when we did absolute value equations at the beginning of the year, we said great or than is an or statement. So it's x is greater than 0, or you flip the inequality and make it a negative, but that's the same. So x can be greater than 0 or x can be less than 0. The only thing x can't be is 0 itself. So it's negative infinity to 0, meaning 0 to infinity. One more, using this as an opportunity to review a lot of our inequalities. X squared minus 4 greater than 0. Alright, you can't just square root with an inequality, so if I factor that, that factors into x plus 2x minus 2. Do you guys remember how we did these? We made our sign line. What makes x plus 2 0? And what makes x minus 2 0? So those are the two things that make it equal to. And then what did we do? We plugged in test points, or looked at a graph, either way. So if we put in something smaller than negative 2, you would get a negative times a negative, which is positive. If you put in 0, you get positive times negative. And if you put in 4, positive times positive is positive. We wanted greater than, which is positives. So it's negative infinity to negative 2, union 2 to infinity. Any questions there? That is my stopping point. There is a handout on